permutations and combinations, and it's about counting how many ways you can do something. Can someone remind us what's the difference between permutation and combination again? Yeah, permutation is a group, but so's combination. So they're both groups. The order doesn't matter with which. Combination. So I want you to always think, if you're unsure about that, because it's like a 50-50 shot, think combination committee. Right? Committee. So if I'm choosing a committee of 4 people from our lowly class of 2, 4, 6, 8, 9, so 4 people from 9, it doesn't matter who's being chosen first, whatever. So if I'm choosing 4 from 9, bingo, bango, bob, that's how we do it. Whereas if it was, I'm choosing 4 people from that and the order is different, so it would be different. Laurie, Ellie, Dylan, Kai would be different to Dylan, Laurie, Ellie, Kai, right? Counts as 2 different if that's a permutation. So more permutations than combinations. Are we happy with that? Right, today what we want to look at is playing a little bit with the properties of this combination stuff. So not in a counting sense, but more in an expanding binomial sense. So Alex, can we look this way, please? At the end of last lesson, we looked at saying that we use this with binomial expansion. So it's my friend, Pascal. Do we remember Pascal's triangle? Yeah, Pascal. So for starters, we make it up by going 1, 1, and then we go 1, but we add these together. 1 plus 1 is 2, then we end with 1. We start with 1. 1 plus 2 is 3, and so on. And you think, wow, this is brilliant. Not really. In years gone by, I've got my year 8s to do this, and they look at patterns that they can see just with the numbers. So they look for square numbers, they look for factors of 3, factors of 5, and you have triangles within triangles. There's so many different things with this triangle. It's amazing. But the main purpose is for when we're expanding stuff. So trust me a little bit, you already know this one. If I have x plus y squared, how do we expand that? X squared plus 2 xy plus y squared. Now, if we were to look carefully at that, this is technically a 1x squared. It's a 2xy and it's a 1y squared. And that's where we have this guy over here. And if I was to then expand x plus y cubed, should remember maybe from year 10, but we went with the whole go x plus y times x plus y squared. So this would be x plus y times x squared plus 2x. And you could sit there and do it, but this hurts me just to write all of this out, right? So you would expand, then times everything through by the y. You'd see that you're going to have another 6 terms where you have to get your stuff together, yeah? Whereas I could just go, this will end up being x cubed plus 3 x squared y plus 3x. Like seriously, I would make you expand this if we had all day, every day. And once again, if we look at this, this is 1x cubed, it's 3x squared y, it's 3 and a 1. And where do we see that in our triangle? Once again, we have 1, 3, 3, 1. Do we see the beautifulness of this? And we can take that a little bit further. So if I now have, let's mix up, well, let's stick with, we've got x plus y to the 4th. So how do we expand that using our Pascal's triangle? Not cubed, it won't be cubed. So when it was cubed, right, so it starts with 1 x to the 4, right? What did we notice about its first term? So we had x, it was x cubed, then it became x squared, then it became x to the 1, then it became x to the 0. Do we agree? So we know the next bit is going to be x cubed, then squared, and so on. But what goes in front of the x cubed? Right, it'll be plus 4x cubed. And what's your y term? Here there's no y. Here it is y to the 1. And I'm writing the 1 there just so you know. Look, 4. 3 plus 1 gives you 4. Normally we wouldn't write the 1. Right, what's my next term? We've got 1, we've got 4. Now it's 6. But now, what's happening to your x? 4, 3, 2. What's going to happen to the y? Squared, right? Because 1, 2, or because you've already got the 2, 2 plus 2 gives you the 4. So many different ways that you know what it's going to be. Plus 4xy to the... Again, justify that because it's going 1, 2, 3. Or because you've got 1 plus 3 has to add up to be 4. Plus 1 y to the 4. Does that make sense? Everyone happy with that? So where we can now take it a little bit further is that I can now say, well, what if my x and my y start to get a little bit more complicated? So instead of just x and y, what if it is 2x plus, or shall we go plus or shall we go take? We'll stick with plus for now. Plus, okay. Oh, maybe not 4, because then we could have pulled out common factor of 2. Give us another number. 5, okay, 5. And we'll go to the power of 4. So, who could expand that now using our rule? Sorry about that. So what did we say happens to our first term? So well done, Alex. I'm actually going to keep it a little bit showing my steps, right? So it's going to be 2x to the 4, but as Alex said, that is 16x to the 4 because everything in the bracket gets the power. Agreed? And that would be technically 5 to the 0, which is just 1, so we leave it. Plus, what comes next? Once again, look at your, it's going to be 4 times the first term, 2x to the 3, times 5. Well done. Next term. So why are we 6? Is everyone okay? So I need you to then, if we put something down and you don't understand, you have to say why. So we're going 1, 4, 6. And now, first term, it's going to be 2x, but to the what power? 4, 3, 2, which means we now have to say it's times 5 squared. Right, 2 plus 2 gives you the 4. Make sense? Plus 1, 4, 6. What comes next? 4 times 2x to the what power? To the 1, so I'm just going to leave it like that. Times 5 to the plus 1 times 5 to the 4. And now if you had to tidy that up, we would say that 16x to the 4 plus 4 times 2 cubed, x cubed times 5. So everything in the bracket gets the power. We're seeing this? And you go, yeah, 4 8s are 32. I'd probably go 4 5s are 20 times 8. Get 160 and so on. And you can simplify. Does that make sense? What's going to happen eventually, where we want to go with this, we can have things like even fractions in here. And I might say it's to the power of 9. I don't want you to do every single term. I want to say what would be the third term? Or what would be the 7th term? And you don't have to do every single bit to get there. Does that make sense? So that's where we're heading. So could I ask you to please open your books to page, I can't see the page because it's zoomed out. Sorry, patience is a virtue. Oh, page 214. And we're going to play a little bit and then we're going to edit. So we talked about this stuff here, row 1, row 2. And we're going to use that now to expand. Oh, they went straight into fractions. Hell's bells. Shall we try and do this binomial without looking at the answer? Yes, they all say with enthusiasm. Now I've asked the class to do Pascal's triangle up to row 5, right? And you can do it like they've done here. Blah, 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 blah. But what we talked about, and that we did over here, what we talked about last lesson was, remember, this row here, this is actually C50. This is C51. This is C52, and so on. So just keep that in mind as you're doing it, because if I now said, oh, can you find out what are the coefficients? Tom, can you please listen? Right, what are the coefficients? What would be the row for row 10? Do you have to go all the way up and make the whole triangle? No, you could just go, the first one would be C10, 0, the second one, C10, 1, and so on and so forth. So just keep that in mind. So is everyone happy that it was, what, 1, 5, 10, 10, 5. I just have to check. Yeah, 10, 5, 1. Should know that. So they said, let us do this, but I'm just doing it with you now. All right, so this is our first term, right? So it's going to be 1 times your first term, and you take that to the power of 5. Okay, that looks like a 6, so I'll just rewrite that. Let's be nice and neat. To the 5. All right, we then go plus. Our next, let's go colour coordinating. All right, is 5, so it's going to be plus 5. We take our first term, and I'm not using brackets at the moment because it's just x. And that's going to be now, it goes 5, 4. But I need to now do my second term. I will use brackets because there's a negative involved. So that's minus 2 over x to the what power? Well, technically, that will be 1. We're good? And then the next one, so that's going to be plus 10. It's our first term again. It's gone 5, 4, so no guesses, no prizes. So for saying that, that's going to be 3. And then we've got minus 2 over x. But what's it going to be now? That's power of 1. This has to be 2, right? Once again, you're checking that this and this, they have to add up to be the power that you had over here. Thrilling? All right, I just want to do one more colour because then I'm going to stop. What colour should I do? Blue. My heart is true. Okay, so it's another 10. And that's now going to be, got excited with the brackets, x, what's happening? 5, 4, 3, 2. All over minus 2. I don't even have to look at the previous term because I know that 2 plus this has to be 5, so that's got to be 3. Why is it minus 2 on 3? Because I got excited. It's x. Thank you, Dylan. Now, you can finish off the rest of it, but what we have to do now is actually simplify everything. So nothing much to do with the first term, that's x to the 5. All right, what we've got happening here. This is to the power of 1, so I've got a positive times a negative. Do we agree? What is a positive times a negative? Negative. Okay. And what's 5 times 2? 10. I've got x to the 4, technically, so I've got x to the 4 times, I should have put that all there, all over x. So I'm dividing here by the same base. When I'm dividing by the same base, what do you do to the powers? Yep, so when I'm dividing by the same base, what do we do to the powers? We minus them. So 4 take 1, we're going to have, that's x 3. Yeah? Okay, with the next one, I'm probably just going to do a little bit of working out, just because this is the first time that you're doing it. When you square a fraction, you square the top and you square the bottom, right? Both the tops and bottom. So what's minus 2 squared? All over x squared. So when I'm now simplifying this, times the numbers, 10 fours are 40, and it's positive there, and I've got x cubed divided by x squared. So that will just be x. Happy days? Right, be careful here. When you've got this one, I've got plus 10x. Oh, whoops. I did that under the wrong one. Bad me. So that was this one. So if I was to simplify this, this is 10x squared. What's minus 2 cubed? Right, negative 8. So you're going to have, you'll see now, it's going to go plus minus plus minus. And of course, we've got x cubed. So what's plus 10 times minus 8? That's going to give you minus 80. What's x squared over x cubed? So x squared divided by x cubed, you can either write that as x to the minus 1, or you can just say that's over x. What do you prefer? I like to get rid of the negatives. But if it doesn't say in the question, then it's, your call. So can you try and finish that without looking at the example and see if you get it right? We're just working through exercise 8E. Cheers. So please make sure that you put in all the steps. So I want to see this line. I want to see that this is 3x cubed plus then 3, right? Because it's 1, 3, 3, 1 is your Pascal's triangle. So 3 times, that's going to be 3x squared. And then it's your second term, so minus 1, technically to the power of 1. Right, plus 3 again. This time it's just 3x. But it is now minus 1 squared, okay? Remember, again, 1 plus 2 gives you the 3, and then last but not least, it's minus 1 cubed. Then you simplify, okay? So 3 cubed gives you 27 x cubed. This one is minus 1. 3 squared gives you 9, so that's going to be minus 9 3s are 27, so minus 27 x squared. If you want to do another line of working, that's more than welcome. Minus 1 squared is 1. 3 times 3 is 9, and that's just to the power of x, and minus 1 cubed is minus 1. Okay, done. Oh. Okay, so this one again, same thing. So there's your first term, second term. So this is going to be 2a. Okay, once again, there's your power, so 2a cubed plus, then it is, oops, so 1, 3 lots of 2a, that's now squared, times negative 1, plus 3 lots of the first term, but it's not squared anymore, right? Remember, 3, 2, now that's just 1, but it'll be minus 1 squared. And I said 1 when it's meant to be b, because I'm listening into other people's conversations over here. Okay, so that will be minus b, and then we finish it off with 1 minus b cubed. Okay, now it comes time to tidy up. Everything in the bracket gets the power, so that's 2 cubed, which we know is 8. All right, we've got a positive, so this will be plus 3 times 4a squared times negative b. Right, positive times a negative, so that's going to be, but negative squared is still positive, so that's just plus 6ab minus b cubed. And I'll just tidy up that middle term. So aa cubed. Right, what's going on here? A positive times a negative is a negative. 3 4s are 12. A squared b plus 6 ab minus b cubed. They're all a little bit the same. You just got to be careful with the negatives. So if you think, oh my God, I'm so over this, I'm done, well, that's okay. You can sort of skip it along. Question 5, you can see I'd maybe pick one of those to do y. Why question 5? It's got square roots. It's a little bit different. So if you're going, oh my God, question 4, I've just done one up here. x take 1 over x to the power of 5. I get this will be the same. It's just the coefficients are not going to be 1, 5, 10, 10, whatever. It's now to the power of 6. So I think I'd be able to do that, no worries, changing the coefficients. Some of you might go, yeah, but I want to do it to make sure that I know it. Your call. Definitely do a square root one, please. I did like question 6. Anyone, just part A, you go, yeah, you'd be able to do that. Look at part B. Now, induction people. Hence, it's a big thing. It means that you must use part A. It's not hence or otherwise, it's hence. How can you use part A? So I don't even have to have done part A to work out this bit here. How can I do? Hence, find the value of 2.01 to the power of 6. Yep. One sum is part A, yep. Sub. They're saying, so can you see that 2 plus 0.01 gives you the 2.01. So you're going to have this big expression with 2's in there, and as Hamish said, wherever the x is, replace it with 0.01, and you should be able to work it out without needing a calculator. Maybe. Who knows? Capiche? So it's worth having 6. I don't think we have to do the rest. What we want to do now is, this is the type of question that you're going to get. Look at that. Write down the first 3 and the last 2 terms of the expansion of this to the power of 12. Oh my God. Keep your hands off your laptop. Does that mean you have to expand all the way and do the, what's his name? Pascal, up to the 12th row. And if you look ahead, oh my God, now it's 14. Do you have to do 14 rows of Pascal's triangle? No, niet. How do I say no in German?
No.
9. All right, we don't have to. We have this beautiful... Excuse me. We're waiting for Tom who's talking. Oh, and we've got 2 Toms. You can guess which one it was. We've got this binomial theorem. So we want to make sure that we write both of these things down, okay? So we've already discussed that with our, where'd it go? With our Pascal's triangle, we can find out what these values are by using our combinations calculator, right? The C combination button on your calculator. So you don't have to actually go all the way down to the 14th row, because I know that will be C 14.0, C 14.1, C 14.2, etc., etc. Oui? So that's what this, I'll put it back on there in a minute. That's what this thing here is saying, right? Why is that not, I mean, technically this would be N0. But we know that's always going to be 1. You can check that on your calculator. C50, I haven't got my calculator open. You can do that yourself. Oui. And then this one here, the general term, right, it tells you what to do. It's got a formula. So can you put this somewhere safe on your formula page, please? These 2 boxes, and then we're going to show you how we can actually do it. So this is the last bit for this little unit, right? And we're saying that find the general term, write down the first 3 and the last 2 terms of this expression. So what we're wanting to say is we do not want to go and do 12 rows of Pascal's triangle. So hopefully what you can see is that the first term will be C12, 0. You can't say 1, right? The first term is actually 12, 0. That gives you, believe it or not, this will give you the 1, which is that first 1 in Pascal's triangle, yeah? And it's your first term here to the power. So it's going to be 2x to the power of 12. Do we agree? Alex, you're killing me with that. I don't think you are, sorry, because you continually do the wrong thing and I'm losing my patience. Well, I know you wanted to get your investigation done. That was for the weekend, not now. And then it's going to be 2x to the what? 11, right? Take 1. But now we have to deal with our second term, which will be 1 over x, and that's going to be, again, you wouldn't write 1, but I'm writing to the 1 just so you can see 11 plus 1 is 12. plus C two, and this will now be 2x to the 10, 1 over x squared. Now, you need to make sure that you read your question, because it says here, do not simplify your answer. And even if it didn't say that, have a think. What do you think 2 to the 12 is? That's a reasonably large answer, isn't it? So if it did say to simplify, the most that I would probably do with some of this would be, well, that's 1, so it will be 2 to the 12 x to the power of 12. I would not actually work out what the coefficient is. I'd leave that simplified. Similarly with this, I would leave this, right? What is C12(1)? Can everybody work that out on their calculator, please? And why should we go, oh, of course. So remember, you go option, you go more, you go prob, right? We go 12, C1, and of course, it's 12. What would be 20, C1? 20, okay? So we start to know and recognize some of these things. By the way, if 20C, oh, we'll go back to here. Might as well do it to the side. If 20 C1 is 20, what else will be 20? Because you know it goes 1, 1, 20, 20. Yes, because C2020 will be 1. Take away 1 from that. C2019, 1 less, will be 20, all right? Do we get, this is one of the things we did, I think, last week, was that 2018 would equal 20 what? 0, 1, 2, yeah. Make sense? Anyway, so yeah, you can go along and simplify where it's reasonable, but in this case, it did say do not simplify. Happy with that? How would you do the last 2 terms? Well, I think we've sort of just talked about that. We know that the last term is going to be C20, 20. Your original one, that's technically to the power of what? 0, so not in it, not in the game, because anything to the power of 0 is 1, and then you'd have 1 over x to the 12. The term before that will be C20, 19, which we've established is going to be, oh, and I'm doing 20 instead of 12. Idiot that I am. Why didn't anybody stop me? Somebody stop me. You just thought I was on a roll. 12, 11, 12. I put 12 there, idiot that I am. What would be my term? What comes after that? 2x to the what power? 1, and therefore it'll be 1 over x to the 11. Is this making sense? Keeping in mind, hopefully you don't need notes for that one. I tend to need to look at this formula. I get mixed up with my N's and R's and all that sort of jazz. Okay? But the general term, R plus 1th term, in the binomial expansion, A plus B to the N is that formula. So if we look over here, find the 7th term. So if I want the 7th term, what is R going to be? It won't be 7. If I make R 7, 7 plus 1 gives me 8, and I'm then finding the 8th term. So if I want this 7th term, right, R would have to be 6. So you always go 1 less. So that's the main thing you need to know. And then the formula is just straight substituting in. Does that make sense? So therefore, R would be 6. And so T, 6 plus 1, aka the 7th term, that's just notation downstairs, is going to be, and I would write this, R equals 6, N equals 14, because I've got so many weird things going on in my head. I don't want to have to think about which one was which again, because I've got 7, I've got 14, and I've got 6. What is what? So you write it down, and then it's a straight subbing in. So remember, this is the same as writing C, right? NR. So what's my N? 14. What's my R? 6. If you want to write it like this, go forth. Right, what's my A? That is your first term, right? So what's my first term? 3x. So that's going to be 3x to the what power? Oh, N take R. What's N? 14. What's R? 6. Times negative 4 over x squared. And of course, 8 plus this has to equal 14, and lo and behold, that's 6. Does it ask you to simplify? It says do not simplify, so don't touch it. But that's pretty much where we're going. All right? So a little bit of homework to do between now and Thursday. God, I hate this line. But basically trying to finish off the previous exercise and this one.